So you know, polygons is like the umbrella that covers them all. So we did triangles. Is a triangle a polygon? Yes. A triangle is a polygon. Is a quadrilateral a polygon? Yes. The answer is yes. Okay, so we're now, it's kind of like we started zooming in, now we zoomed out. So over top, polygons would be your triangles. Quadrilaterals, and everything else. The only must is it has to be a closed shape. Okay, so if it's not closed, then it's not a polygon. So one thing that I want you to highlight right away as we go over polygons is that they have the same number of sides and angles. Okay, and I will already give you a heads up. N stands for the number of sides in this unit. Okay, so if you see N, we're talking about the number of sides of given polygon. Okay, and so you don't need to know the difference between these two for this course, but I will still, you know, present this to you. So there's convex polygons and concave polygons. Think of a shape caving in. If it were to cave in, we call them concave. We are only dealing with these ones, okay, in this course. This course only deals with convex, okay? And another thing, please make note of this because it's not explicitly stated elsewhere. So we have a distinction. The province will test you whether you understand the difference between a regular and irregular polygon. You just have to make sure you know what a regular polygon is, because then you know that everything else is irregular. So here it is. For you to have a regular polygon, okay, all sides are equal and all angles are equal. That is what makes a polygon a regular polygon. Everything else is an irregular polygon. So there's no such thing as, oh, almost regular, you're almost regular. There's no such thing. You're either regular or you're irregular. So regular right here, this is an equilateral triangle. What do we know about the angles? They're all 60, right? All sides measure the same, all angles measure the same. Check. That one would definitely fit the category. What about, is a square a regular polygon? What do we know about a square? All sides are the same and all angles are 90. So is it a regular? Yes. Okay, check. What about over here on this side? Let's just zoom into any one of them. I like to zoom into the rectangle. What do we know about the angles? They're all 90. Oh, wait a minute. We're halfway there. All angles are the same. All angles are equal. That's the first condition that needs to be met. But the sides are not equal. Okay, they're not equal. So therefore, it's in the irregular category. Okay, so let it be known that that's, so basically there's a divide here. Regular versus irregular. Okay, let's keep going. I I will test your knowledge on that. I'll find ways to be like, you know what a regular is, okay? Properties. All polygons have interior and exterior angles. Interior angles are supplementary. Interior and exterior angles are supplementary. They have a sum of 180. So here's what I mean. I'm going to use two different colors, red and blue, because I like them to stick out, okay? How many sides does this polygon have? This is what I suggest you do, okay? Because they can get up there in a number of sides. Put a check mark on the side you start counting. 1, 2, 3, 4, 5. That way you don't double count, because I see that all the time. Put a check mark. So 1, 2, 3, 4, 5. So n is equal to 5 sides. Okay, so n for us would be equal to 5. And there are 5 interior angles. So there's one interior angle right there. There's one right there. There's one there. And how many interior angles do we have? I'll go 5 interior angles. And now the exterior angles, okay? So I'm going to use a ruler for this one. You don't have to, you'll be fine, but I want to emphasize that an exterior angle, there's only one per corner. So what I do is I just take this side, for instance, and just extend it. It's a dashed line. It's not a solid because it's kind of not part of the triangle, that side that you're creating, but it allows you to draw your exterior angle. So this part is the E. Can you see that they add up to 180 degrees? Does it make sense if you see them side by side there? Yeah, right? So I'll just say here, I plus E is always equal to 180 degrees. Always. And because of that property, folks, we can make two conclusions. We can say that if we know what the interior angle is, in order to find the exterior, guess what we're going to do? We're going to go 180 minus the interior angle. So that'll help you. If you have the interior angle, boom, you take it away from 180, you get your exterior angle. At the same time, you can also conclude, if you know your exterior angle, you can immediately find your interior angle. You just have to go 180 minus E. This is something that I would strongly suggest you have on your study sheet. If you have room, maybe just zoom into one of these corners and tell yourself that. Like that way you know what the letters mean. Okay? If you have room on your study sheet, so let me try this for instance. If you have just zoom into any particular corner and just tell yourself that this is I, that's inside the shape, and this is E, which is the exterior angle right there. So then you know what we're talking about. Anyways, you continue this, every corner has an exterior angle. Make sure you know that you're extending one of the sides of that polygon. Because sometimes students are like shooting rockets into space kind of thing. So this, I've seen students do this like, hey, this is the exterior angle, what is it? They go out like that from the corner. It's like, no, you got to extend one of the sides, right? So don't just come up with a dashed line. You're extending one of the sides of that polygon. How many exterior angles? 1, 2, 3, 4, 5. You see that? 5 exterior angles. Just by looking at this, would this be considered a regular polygon? The sides don't all look the same, right? Okay. So just so you know, the interior angles would probably all be different as well to a certain degree. So that's that. Another very important, I want you to add this to your study sheet. The sum of exterior angles is always equal to 360 degrees, regardless of regular or irregular, regardless of the number of sides. Example, a triangle. The exterior angles add up to 360. Example, a quadrilateral. Let's do a square. The exterior angles still add up to 360. Example, a 100-sided polygon. Can you see that? It's a bit small, right? I apologize. The exterior angles, the sum of exterior angles is still equal to 360. I'm talking about the sum of all the exterior angles. Okay, the sum, adding them all up would always be 360. That's kind of a cool property. No matter how many sides, if you add up all those exterior angles, it's always 360. Okay. So it's the sum. I should say the sum, because otherwise you're going to tell me, Mr. Dirksen, you said that every exterior angle is always 360 no matter what. No, no, no. Adding up all exterior angles adds up to 360 every time. That's what I'm saying. Okay? All right. Let's keep going. I'm going to give you formulas. And here's where I'm going to kind of deviate a little bit in terms of whether or not you're going to add this to your study sheets. Here are the formulas that you must know how to use for polygons. I'm telling you right now that it may look overwhelming. It all has to do with the number of sides of that polygon. You see n everywhere, right? N is everywhere. So on your formula sheets, the green one, these formulas are all given. They're given to you here. So S stands for the sum of interior angles. I, right? I is stands for an interior angle. E stands for an exterior angle. C is for central. D is for the number of diagonals, where N is the number of sides. So they are here. It's up to you if you want to just rely on the formula sheet or if you want to add to your study sheet, because I'm going to give you a little bit more than just the formulas on the formula sheet. So here it is. I'm going to just write down under this S. This is a little scary here. Please don't really worry about the N in brackets so much, but this is the sum. S stands for the sum. I tried something cheesy here because I was like, you're going to be psyched to learn about this. I know that's not how you spell psyched, but I tried something, right? I is the interior angle. C is the central angle. E is the exterior angle. D stands for diagonals. Sum, interior, central, exterior, diagonals. What stands out? I don't know, did you notice that central and exterior have the same formula? You notice that? That's something cool, but, right? Just so you're aware of that. And I also have, everything is described here. However, you need to make sure you understand that ice can be actually drawn, it can be identified on the diagram, and only works for regular polygons. Ice only works on regular polygons. And here's why. Let's focus on the exterior angle here. My pencil is right hovering on it. What are we doing? Like, why are we going 360 divided by the number of sides to find an exterior angle? I just told you, what is the sum of all exterior angles every time? And we're just dividing it equally amongst the number of sides, right? When you divide by the number of sides, you're saying every single angle is exactly the same. Does that ring a bell? Does that make sense, right? If I say, hey, it's got 10 sides, right? I'm just going to take the 360 divided by 10. Now I know that every exterior angle is 36, right? We're assuming they're all the same. So these formulas only work for regular polygons, just to keep that in mind. Another thing I want you to add is that interior angle can be found like this, using that formula, or I gave you this one on the previous page. I is equal to 180 minus exterior angle. That's another way of doing it. So add the or and then this right next to it. Same thing for the exterior angle. You can use this formula, or exterior is 180 minus I. So they're kind of related, okay? Let's go and find ice, okay? I want you to know where it is. You need to be able to identify it. Several exams have asked students to do so. So let's go to this pentagon down here. It says here label ice, so the interior, central, and exterior angle, then calculate the sum, the interior angle, central, exterior, and diagonals. We'll do this in a bit. So let's focus in on this. If I asked you for an interior angle, all I would need you to do is make an arc at one location and put an eye there. You've identified one interior angle. Okay, you're good. We know, you know where the interior angle is. A central angle, you got to go to the center, make a dot, and then make a pizza slice, basically. You go from one corner to the center, then you go to the next corner. It has to be the next one right next to it, and then come back to the center. This is one central angle. Make sure you label that, you know where it is. And now you need to label one exterior angle. I like to have interior and exterior right next to each other, so I'm just going to extend the base here and make the exterior angle outside there. That's what I call ice, right? Interior, central, exterior. You need to be able to identify it. Okay? All right. How many central angles do you think there are, though? N is equal to what? How many sides does this have? 1, 2, 3, 4, 5. 5 sides. Which means it has 5 interior angles, 5 exterior angles. How many central angles, if you could guess? 5, right? There's technically, if you slice this up, there are 5 central angles around here. We've just identified 1. So there's 5 C's as well. Okay, so that's something that you need to know. So let's calculate in no particular order. I'm going to just start with S. The sum is equal to N minus 2 times 180 degrees. N is 5, right? So you just go 5 minus 2 times 180 degrees. that is 3 times 180. That gives you 540 degrees. Do you think this would work with a triangle as well? This formula, the sum of interior angles of a triangle? Let's try it. 3 minus 2 is 1. 1 times 180? 180. It's always supposed to be 180, right? For a triangle. What about a four-sided shape? 4 minus 2 is 2. 2 times 180 is 360, right? So this works for any polygon, any shape. In this case, it's supposed to be 540. How is that useful? Well, we could figure out, like, if we have 4 of the 5 angles, we can find the missing one, and so forth. Okay, let's do another one. I, interior angle. You can use I, you can write interior. The formula goes like this: n minus 2 times 180, but this is the difference. It goes divided by n. So the interior angle is 5 minus 2 times 180 divided by 5. The interior angle, therefore, is 3 times 180. What does this look like to you, the top part here? Didn't we just do that? Right? You see that? So we're repeating it, but so we're going to find the sum, but we're going to divide it by 5. We're going to figure out the sum of all, and then we're going to divide it by the number of sides to just find 1. That is, go 3 times 180 divided by 5. You're going to get 108 degrees, pardon. That is your interior angle. So every interior angle measures 108 degrees. Next, let's do the exterior. Exterior angle is 360 divided by n. So the exterior angle is 360 divided by 5. 360 divided by 5 is 72 degrees. Does that surprise us? You see interior and exterior? What did they add up to? 180, right? That's what we expect to see. So you can say, or to figure out the exterior angle, we could have just gone 180 minus 108 and still arrive at the same conclusion, that it's 72 degrees. I will highlight the fact that I used this 108 here and I subtracted it there to come up with the exterior angle. We're almost done. Central angle is 360 divided by n. Exactly the same formulas, you see? So we're going to actually cut to the chase and just say that the central is 72 degrees. Question, does it make sense that for the central angle, we go 360 divided by the number of sides? What is the full circle around here? A full circle is 360. So there's 5 sides, right? So if you take the 360 divided by 5, you're equally breaking the central angle down, right, to each individual central angle. So that's why it's the same formula. One more. This one is not an angle. D. I inserted this for you guys here so you know what it does. What does this formula do? Calculates the number of diagonals that can be drawn. The province allows you to actually draw them and count them. Please don't do that, because if you even get one wrong, you're not going to get the marks. But you could draw them. That's an acceptable method. The more sides you have, the crazier the number of diagonals get. So please just use this formula to figure out how many, okay? So let's do this for the pentagon here. I don't know where you have space. I hope you have some space. Let's do D right here. Diagonals, it calls for n times n minus 3 divided by 2. This is the only of the formulas that has a divided by 2. Please don't have a divided by 2 anywhere else. Some students make that mistake. Okay? This will be 5 times 5 minus 3 divided by 2. 5 times, what's 5 minus 3? It's 2, right? 5 times 2 divided by 2. Now you either realize that times 2 divided by 2 cancels out, you're just left with 5, or you just go 5 times 2, that's 10, divided by 2 is still 5. So 5 diagonals. I apologize for the crammed in answer there. 5 diagonals. And for some of you, you might appreciate this, so I will make a little pentagon here. And so it states we can draw 5 diagonals. So let's do this. 1, 2. I'm going to use a different color. 3, 4. And I'm running out of colors here. Let's try this one. There's one missing, right? I'm going to use green. This one right here. Okay. So 5 diagonals can be drawn if you wanted to, but I would not recommend that because you will probably miss one. Like once you get into the bigger, like 7-sided, 8-sided, 9-sided, drawing them can be quite the task, quite the challenge. Okay. So D is not a degree. Okay. Don't put degrees on that answer. It's the number of diagonals. Okay. Okay, I'm going to stop talking a little bit. I'm going to ask you to calculate this, practice these formulas, using these 5 formulas. So, there's 5 diagonals, yeah. The formula kind of told me that, so I just go by that. So let's go to 52. I will not ask you to do every single question. So for now, if you go to page 52, I will just ask you to focus on B. So I want you to label one interior, one exterior, one central. Write this down, please. So label one interior, one exterior, one central. Then calculate psyched. And by that I mean use all 5 formulas and do the math somewhere around this region to figure out what they are. I'm telling you, sometimes these are worth easy 1 or 2 marks, okay, these questions. If you're done B, move to the very last question here at the bottom of this page. Do that one. Okay? I'll let you practice this a little bit.